Everyone. Thank you very much for attending this session. I'm really happy to be here with you today. As told by Javier, I will talk about how iTwin Capture and Cesium, both now part of Bentley systems, work together to propose a seamless experience around reality data. The structure of this presentation is quite simple. First, I'll share a clear description of iTwin Capture, its role, the main capabilities and benefits. Then I'll have a very brief section about iTwin Capture Cloud, how all the tools exposed in section 1 are made available through a unique cloud offering. And finally, probably the core of our session, how iTwin Capture integrates with Cesium Ion to propose complete and unmatched reality data experience. We'll talk about integration details, associated benefits, there will be a live demo, and we'll conclude this with quick talk on subscription plans. So a last word before engaging with section 1, iTwin Capture core capabilities. Why are we doing so? Why are we, Bentley Systems, developing complex solutions around reality data to feed digital twins? Well, because you professionals are facing multiple challenges in your day-to-day work, and it usually starts with the need for existing context. How do I get a digital and accurate vision of current situation? Very often, this is the first question asked by surveyors, mappers, inspectors, or others. And subsequently to this question, how do I capture the required data to get this vision? How do I store it? How do I share it? How do I handle multiple formats, data type coming from multiple providers? And probably more importantly, how do I do all this in a smooth and efficient way? Well, answering these questions is really the mission of Bentley and iTwin Capture plus Cesium solution. We'll try to discover now how it goes. So section 1, iTwin Capture, role and core capabilities. iTwin Capture is not one single product, it's a brand. It's a suite of products and cloud services built on 3 major pillars: reality modeling, reality analysis, reality management. And to address the challenges we just described in previous slide, we will rely on these 3 pillars to deliver the most effective solution possible. Capture is about how field data will be collected and transformed in a way that it serves design, maintenance, or operation workflows. Analysis is about how valuable information will be extracted from reality data to meet delivery expectations. And management is about how all this data will be securely stored, shared, and made accessible to the right persons. So modeling first. The main core capability of iTwin Capture in this area, if you had one thing to retain about iTwin Capture modeling, that's the following. It automatically turns images or point cloud captured in the field into the highest quality reality mesh. As suggested on the video, you'll simply shoot photographs following suited capture path, push this raw data in iTwin Capture, and obtain a clean reality mesh a few minutes, a few days, a few weeks, depending on the dataset size and your hardware resources. So almost no manual intervention, purely automated 3D reconstruction. So why would you choose iTwin Capture if you are a professional manipulating reality data? First, it is accurate. As told, the meshes processed by iTwin Capture are probably the best on the market. Besides that, specific features will allow you to ensure strong georegistration with GPS tags or ground control points handling. Quality control tools around it are also provided and will help you make sure you deliver engineering-ready content. So accurate, versatile. In the video, I showed you a drone capture over a campus. This is a very common workflow, not necessarily above a campus. It can be facility, road, rail, district, whatever, but drone flights are something that has become mainstream. But iTwin Capture is actually not limited to it. It can handle images or point clouds of any type, any format, or any resolution from a smartphone camera to high-end aerial multi-camera system, from cheap fisheye lenses to the most expensive full-frame cameras. Of course, the quality of the output is tightly linked to the quality of the input data, garbage in, garbage out. But iTwin Capture is agnostic on this front. It will crunch your data. It will crunch your images or your point cloud. So accurate, versatile, it is scalable. iTwin Capture modeling capabilities can handle data sets of any size. Hundreds of thousands of megapixels can be crunched at once to deliver a single reality mesh. Helsinki, Dublin, Denver, Philadelphia, and many other cities have been reconstructed out of hundreds of thousands of images. And this is made possible thanks to our smart tiling mechanism. This mechanism is also key in the distributed computation aspect of iTwin Capture. Multiple instances can simultaneously work on the same project to drastically accelerate processing time. And beyond processing scalability, smooth visualization of dataset of any size is also a major question. I'll cover this when we'll come to the Cesium ion part, but yeah, this has also been successfully addressed by our solution. So last one, interoperable. What do we do next? Once the mesh, the point cloud, or the Gaussian splats, latest coming in our offering, have been processed, how do we make sure this output can fit in your usual application? Well, we need to support multiple formats, and we do. Ahead of them, 3D tiles, most popular open standard for everything around reality data and 3D geospatial. So first pillar, reality modeling ensures accurate, versatile, scalable, and interoperable reality data processing. Sorry, was I muted for the last?
Yes, Arnaud, we were watching the video, so
okay,
I didn't hear
so
any audio.
Sorry.
Yeah.
I'm really sorry about that. So yeah, the video did not, well, it was probably understandable, but I was just mentioning that reality management is the second main pillar. It's not probably as flashy as modeling. You don't have this nice 3D stuff, the navigation, etc. But it is super important, especially in the cloud-based story I'm about to tell in this presentation. And this iTwin Capture management layer is the foundation around which modeling and analysis capabilities are articulated. By granting appropriate permission level to the right stakeholders, by enabling a secured connection to all reality data available in given projects, it participates to the success of the entire solution. And it ensures the right and up-to-date information is available on time to the right persons so they can proceed with their workflow. So reality modeling, reality management. Now with the last one, reality analysis. Even though clean, accurate, and accessible, a raw reality mesh is not always the final expected delivery. How do we get classified point cloud from it? How do we get a vector map? How do we assess change detection, profiles and cross-sections, or curvatures? That is the role of reality analysis. And through a very wide toolset, reality analysis side of iTwin Capture will allow you to extract the valuable insights you need to close a delivery. For example, what we have on screen is automatic asset inventory in a tunnel. We have the fans, the safety exits, cabinets, traffic lights, that kind of things, on kilometers of roadway. We have the same example for rails, equipments like switches, rails, poles, portals, and that kind of things. And this tool set, the reality analysis one, spans from very basic coordinate or distance measurement tools to most advanced AI-driven 3D segmentation pipelines. It can be leveraged on any reality data, images, point clouds, orthophotos, meshes, or Gaussian splats. We could describe it as the 4 following families. The first one is probably the most basic measurements. It's probably part of most of geospatial solution, but still deserves to be mentioned. Coordinates of point A in given spatial reference systems. Distance between A and B. Height of this pole, area of this district, or volume of this stockpile. That's, the first group. The second one is what we could call the comparison or evaluation tools. How is this automatic work performing against ground truth, something I manually annotated? I know it's real, I know it's good, 100% perfect. How do I compare against it? How close is reality against design? Where are inconsistencies or clashes? These are questions that will be part of it. Cross-sections, profiles could actually also be part of this category, the comparison, evaluation. The third one, the third one is geometry-based feature extractions. Examples. A point cloud is captured along a railway. This is basically the example we had in the video. I need rails and catenaries to be extracted as lines. I don't just need a RGB point cloud viewing those rails. I really need the lines to be extracted to do some cumulative linear measurements or that kind of things. Or other example, a point cloud is captured on a highway. I need road mark to be digitized and delivered as shapefile format. Well, this is doable in the most automated way possible in iTwin Capture. And finally, the last and most recent group of analysis, the AI-driven feature extraction. Object detection from images can be traffic signs, license plates, or human faces for anonymization, for example. Defect detections, cracks or spalling impacting a concrete infrastructure. Point cloud segmentation, ground extraction, city classification, trees, or point cloud artifacts, these floating features that are impacting the capture that needs to be cleaned up before any workflow. All these elements can be detected automatically in your reality data. We, Bentley, propose a small library of AI detectors that can be used straight away by reality analysis. And the beauty of it is that we are not strictly limited to this small AI library. We also offer the ability to train your own custom models out of your own reality data for a more tailored usage and so better performances. So back to our initial diagram, iTwin Capture for management, modeling, and analysis of reality data. All of this chain is historically quite desktop-oriented. The first product that achieved a part of this whole solution were desktop. I told iTwin Capture was composed of a suite of products. Most of them are historically desktop products. But what is super important and what makes the iTwin Capture plus Cesium Ion story possible is the availability of these features as a robust set of cloud services and API. Everything or most of what I showed earlier is not only available in the desktop environment, but also as a cloud service and robust, well-documented APIs. So let's discover it now. Let's focus on this part. iTwin Capture Cloud. Most of the capability previously described are available via dedicated cloud service. If you are a developer or a software integrator handling reality data, this is surely made for you. While going on developer.bentley.com and owning an iTwin Capture Cloud subscription, you will be able to leverage one of the 4 available cloud services, modeling, management, analysis, we previously described, and conversion, that is not strictly part of the story, but that will allow format conversion for downstream workflows. Sorry, I jumped a little too fast. And I will now, before moving on, quickly share my screen to show you what it looks like on iTwin platform. Here we go. Jovian, can you confirm you now see my screen?
Yes, I can.
Good. So as told, here we are on developer.bentley.com. That's the iTwin platform. This is where you will find all the Bentley cloud services and related documentation. If we scroll down, there is everything you need to understand what it looks like, what it does, what services are available, and so on. If you focus on what is of our interest today, we have something called reality capture here, and we have more details on what is going on, what it does: automatically produce 3D models from photos, perform automatic error triangulation and 3D reconstruction, etc., etc. And we have our 4 and now 5 services. Actually, this one is super recent, still not exactly part of our story, but you get them. Modeling, management, analysis for the main 3 ones, and this one will become important, not currently for our story. Reality modeling, if we take a closer look, we will have here a vision of what it does. We will have documentation on the input, we will have documentation on the production settings, and we will have some examples as well. Let's assume I have a collection of drone images. I want to turn it into a reality mesh. I can go here, create a job, try this out, and I have a full example that will show me what are the inputs, what are the outputs, how do I define settings, etc. I will be able to start playing with it, execute, and in the end, a reality mesh will be posted on reality management and available for any downstream workflow. So this is how it works. All the documentation here is open and available. And for those who will have dedicated subscription, they will be able to play with it for modeling, but also analysis of reality data. Back to our slide deck. So iTwin Capture, the core capabilities, management, modeling, analysis, all this available into a cloud service. And now, probably the core of our session, Cesium Ion and iTwin Capture integration. Cesium, you probably all know it, is a platform for developing, hosting, viewing 3D, geospatial, and reality data content. It is primarily focused on real-time rendering of large-scale datasets. It enables developers to build immersive visualization apps using reality and geospatial data. Cesium's strength lies in its flexibility and its ability to efficiently stream vast amounts of data. Super powerful, but even though not strictly limited to it, quite developer-oriented. If you're not what if you're not comfortable in developing? What happens if you don't really type code or really understand this language? Cesium Ion is a web app that provides tools for preparing, hosting, and streaming geospatial and reality data at scale. It will be the answer to this question. It simplifies the process of converting raw data into 3D tiles that are optimized for web application. And it allows for animation or virtual tours and allows to set this up in a very fast and intuitive way. So I'll go through this in our live demo and I'll show you. You'll very quickly notice how it is easy to show and present your work around reality data. So focusing back on today's topic, iTwin Catcher plus Cesium Ion. iTwin Catcher is now available from Cesium Ion. From this dedicated web app and without any coding skill, you will be able to manage and share reality data, leverage it for 3D reconstruction of meshes or Gaussian splat or point cloud, and trigger advanced point cloud-based AI analysis. What happens in the back? Cesium Ion calls the cloud services I just introduced in previous section and delivers the output that are shareable and visible straight away in Cesium. Once done, it also offers the ability to create shiny presentations involving viewpoints, annotations, transition in between all of this for a clear and understandable rendering. So I will share again my screen and we'll now go through a quick demo, live demo of iTwin Catcher integration in Cesium Ion. Share again. Jovine, sorry, can you confirm again you see my screen?
I can, yes.
Cool. So you can access this in your web browser, search for Cesium Ion. You'll fall there. If you don't have yet an account, you can create one. I'll come to it after this live demo, but basically this is where you fall. On the top right, I will open Cesium Ion and we'll be able to start the demo. I'll skip this for the moment. We'll come back to it right after that. And I'll start with my assets section. My assets, this is my portal. This is where I will manage my reality data, and this is where I will be able to push or create new ones. So all of this is the reality data to which I have access that I will be able to stream, that I will be able to potentially share, etc. What we will do together is one, take a bunch of images and transform them into a reality mesh. So it all starts here at data, add files. I will grab a bunch of images. It's a bit, I say a bunch of images, but it's actually 5,000 images. I will give it a name. So the asset name, what is it? We'll call it GeoWeek Demo. And what kind of data is this? Is it ortho imagery or photos for 3D reconstruction? Since I uploaded JPEGs, it automatically recognizes the format and proposes me a restricted list of what is available. So here we go for 3D reconstruction. Do we want to make it available for download or not? We can do this later. No big deal for the moment. If you recall about accuracy, here we will be able to use embedded GPS coordinates. We have our TK GPS coordinates, super accurate, that will ensure the resulting reality mesh will correctly plot on the background map. So of course I want to use it. Output quality, draft, medium, extra. This is the quality of the mesh. Basically the level of detail you will be able to reach thanks to the images you input. Of course, performance-wise, draft is much faster than extra. Quality-wise, extra is much better than draft. That's quite basic. By default, I will process a 3D mesh. It also proposes me 3D Gaussian splat and point cloud. I will enable point cloud. I will just reserve 3D Gaussian splat for a side note in a few minutes. Let's not cover this for the moment. So super simple. I just bring some images, choose what I want to do out of it, to obvious settings, press upload, and it starts. So on the bottom right, I have a progress bar. As told, it's 5,000, almost 5,000 images. It's huge, probably half a day to compute. So of course, we will not complete this and we will jump straight away to the results, but I just wanted to show you how easy, intuitive, and simple it is to move on with such a computation. So just let's cancel this one and we'll move to the results. So I will just disable this. We'll delete it afterwards. As told, here I have all the reality data I have access to. I'm able to filter out anything I want upon the format or the type, sorry. I want 3D tiles. Well, almost everything is 3D tiles. This doesn't help me much. So I will try to retrieve from the name, and here is what is of my interests. So these two, Abilene data center point cloud are resulting from the processing I just submitted before. It was just computed a few weeks ago, but this is what you would obtain if I would have let it run for real. If I click on this, I can have a quick view of my reality mesh. Here on the right, I'm able to extend this and I can start navigating. It's correctly plotted on Earth. There is some Z issue. We will fix this right after that, but X, Y are correct in terms of Z value. I'll show you what is going on. That's our mesh. We have the very same scene as a point cloud. So likewise, I can view and navigate. If you recall, when I talked about iTwin Capture and associated benefits, it's not only iTwin Capture, of course, it's iTwin Capture plus Cesium ion, but here we are viewing, I don't know, I think it's just 5 GB, but the mesh is probably about 20 something gigabyte, and it's super smooth, super fluid. So this is also about scalability. It's not just processing scalability, being able to process the very large dataset. It's also about viewing very large dataset. And we are really in this situation here. We are not experiencing any lag or whatever. It's super performant. So yeah, point cloud, no, sorry, 5 GB for the point cloud, but 29 for the mesh. Maybe one last thing before I move on to the story and the presentation. If that's not the point here, but if I am a developer and I want to add some layers or do some fancy things, I'm able to open the Sandcastle and start customizing this with code. So not for today, but just know that it is available here. So my mesh and my point clouds are complete. I like to create a story. I like to share this in a fancy way so it's usable and viewable by decision makers. I have something called stories here that I will be able to use to do that. So I will create a new story, and just like the mesh creation process, you will notice how easy it is. First, I will name it. So I will call it GeoWeek session. Introduction. This is my first slide. It works a bit as PowerPoint. First thing I'll do here, I will add an asset. So Abilene Data Center, I will add this one. Okay, it's now available. I will hide it for this one and I will create a new slide. I will enable this and I will zoom in. All right, so now I have my reality mesh. Again, you notice that there is still a problem with the Z value. Before it was floating above ground. That was terrain reference, ellipsoid terrain reference. Now Cesium world terrain, we have some conflicts. Very recent features allows me to clip this, to make this very friendly, very nice. So I just drag the handles to the extent. Unfortunately, it has a weird shape. It would have been better if it was more squared, but let's take a few more seconds to do it the clean way. And here we go. I save this, and now my mesh is perfectly viewable. Okay, so slide 1, I had this. Slide 2, I want an overview of my reality mesh. I can name it mesh overview, for example. Capture view. Then I will create a new slide because I want to zoom in on my buildings. New slide. I can name it Zoom 1, for example. And then I will create another slide on which I like to, maybe here, new slide will be called Zoom 2. And on this one, I'd like to digitize 2 or 3 buildings. So I will be able here to go and run some annotations. Right, I will save it. I will just create one or two others. Okay. Here we go, and the last one. All right, so capture view, and here we go. So what we did here, we opened Cesium Ion portal. We dragged and dropped basically a bunch of images, submit processing. And now in a few clicks, we have something that is really nice for navigation. And afterwards, I'll show you how to share it. Introduction, the globe, mesh overview, all this super smooth. Zoom 1, Zoom 2, and we can navigate like that. Right? So I will keep building this with the analysis part, but before that, I'd like to do a side note about Gaussian splats. They don't really fit in this story because unfortunately, the data, not unfortunately, it's just that sometimes it doesn't apply, but the data that was captured here does not really benefit from Gaussian splats. Gaussian splats are a new 3D rendering technique. It can be seen as a quite sparse point cloud, actually, to which we will attribute some ellipsoids, to which we will attribute color, transparency levels, etc., and that will end up in something that is much better than photogrammetry, than traditional photogrammetry on shiny surfaces, reflective, water, difficult surfaces, and thin elements. So to show you this in action, I will show you another data set. This is, that's the one. This is a bridge in Amsterdam we captured for a European Infrastructure Conference a few weeks ago. And these are Gaussian splats. And if you are familiar with meshes, if you are familiar with photogrammetry, you will quickly notice the benefits of Gaussian splats. This is a cable stayed bridge, super hard to reconstruct for a mesh. And I have a quick story that features the level of detail you will be able to reach. So again, the reason why I show you this on another data set is because the features here are much more, how to say, take much more advantage of Gaussian splat technique. Okay, all the cables, all the wires, etc. So when you are back to my assets here, and if you have a data set that is suited for it, when you will add your data, you can ask for not only mesh and point cloud, but also for Gaussian splats. So we covered a bit of management by uploading reality data, viewing it, etc. We covered the modeling by transforming images into a reality mesh into a point cloud. And I'd like now to show you the analysis part. If you recall, we processed a mesh, but also a point cloud. The point cloud is available here. I showed it before, the very same one. Here I have something called Analyze. I just click on it, and I have available here all the AI detectors that I listed in my reality analysis presentation. We will be able to extract ground, city classification, ghost points, light poles, railroad classification, and trees. This bears on point cloud. And of course, you need to be as close as possible as training conditions. So for example, ground extraction was trained on point cloud coming from photogrammetry, captured from drone, etc. If you try to extract ground from a terrestrial smartphone camera, it might not work. But if you are as close as possible to the training condition, the results can be super good. So if we want to extract bare ground, we will do exactly the same. It's super simple. You select the detector, you press Analyze, and just like before, I will not run this analysis job. It will take a little while, much faster than the modeling, but still a little while. And instead, I will show you what it looks like once it's completed. So I will just search it again. I don't recall exactly which one it is. This is the one, Abilene Data Center Terrain. I can preview it here. As its default view, it doesn't feature any classification. So I will go back to my story to feature this, which one was it? This one, I think, to feature this classification. So I will set here, I will create a new slide. I will move on maybe a little further here, for example, capture view. And now I will replace my mesh, not replace, I will just add my terrain here. I will hide the mesh and get the terrain. So just like before, ideally, I would need to do the same crop. It's just that I would need to do it again. So I will just save it like this. I will not edit the boundaries, but basically it just does like that. So I'm back here, and instead of having this raw point cloud, I will also be able to edit the classification, edit the style. I can either use one that is already existing or create a new one. So I can go for new style. This will be classification. It's categorized. If I press next, I will remove everything here. It results from a previous one, and I will add one that is the number for the ground. I will make it yellow. And I will add another one for non-ground, that is 2. Plus, and save. Okay, and now I have my terrain that has been extracted. So the whole chain is quite simple, even though in the back there are real intensive operations that are computed. We have images, we bring them in the portal in Cesium Ion, we reconstruct a mesh, we reconstruct a point cloud, we view this mesh as a point cloud, very smooth way. And from the point cloud, we are able to extract ground, buildings, trees, vehicles to perform any viewing or other operation. So I will capture view. I will create maybe a new one like that. New slide. And I will create a new slide and go back to the mesh and capture view. So maybe one last thing I'd like to show you before moving to conclusion. This is not yet available in Cesium Ion. This is only available in the global iTwin capture offering, but we can hope that soon it will be. I mentioned that we have an AI library, but I also mentioned that we can create custom AI detectors for very specific purpose. This is what we did as an example here. If I add this data set, I will enable it. I will zoom onto it. Here we are, maybe get this level of zoom. This data set is classified, meaning if I go here, edit style, this one is good. Okay. So for this one, we have beams, cabinets, pipes, rooms, scaffoldings, vehicles. This has been classified thanks to AI, thanks to a custom AI detectors. So I can capture view, move on here. I will just create a new slide. I will hide the terrain, go like that. Okay, capture view. All right, maybe a last one. New slide. And here we go. So again, I'm repeating, but I just like to make sure it's understood and how simple it is. Images to a mesh to a point cloud that can be classified thanks to AI general library, or possibly in the future, hopefully in Cesium Ion, if not today doable in general iTwin capture offering with a custom detector. And based on that, I can create very easily and very quickly stories, just like I did here. If I want to present this to customer or anyone else, I will be able to go through it. And just like I would do with the PowerPoints, I say, okay, we have global approach, we have a reality mesh on the specific buildings, we have this and that. On this one, we have 3 targets or areas of interest. If interested in the ground, this is what we will be able to show you on this area, this one. And if you are more interested in deeper classification, in higher level of customization, we can also do it. Check this out. And this is how it works. And in 10 minutes, we managed to create this story in a super easy way. And this is shareable. You can enable sharing, share the URL to anyone, and he will be able to perform the virtual visit I just went through. So if we had one thing to remember about this demo, super simple to manage your reality data, super simple to process it, and super simple to visualize and animate it. And that's the real added value of Cesium Ion plus iTwin Capture. I will stop sharing my screen and we'll go back to the main slide deck. So before moving on to the conclusion, a very quick word about subscription plans. If interested in what you saw, if interested to test what we just discovered together, you can go for the community plan. It is free, so of course limited, but it will give you a taste of how it works and how it could apply to your work at scale. Simply create an account if you don't have one yet and start playing with it. And then commercial and premium plans offer more processing capabilities and a better level of support. These are public pricing. For more details, I encourage you to check website pages or reach out to me. The last one about the content of the different offering. Differences are mainly about storage space, processing capabilities, and amount of load operation. Like any offering, price increases with capabilities. Maybe one last note on this front, we also have enterprise or custom pricing for organization that will have very specific needs or would far exceed standard plans. So if interested, specific conversation with our sales team will be probably the right move. All right. Yeah, I think I'm done. Yeah, that's it for this presentation around iTwin Capture and Cesium Ion working together. I hope you found it interesting, and we'll now be able to move to Q&A session. So, Jovine, I think.
Thank you. So thank you for a great presentation, Arnaud. It's now time to move into our Q&A session. As a reminder, if you have not already done so, to ask questions, you can use the Q&A box to hit send and submit some questions to us. We do already have some great questions here to get started with. Our first question, what is the average processing speed to turn an image collection into a reality mesh?
If done on iTwin Capture Cloud, like I showed before, we are probably around 200, 250 gigapixel per day. It can vary depending on the structure of the capture and that kind of things, but globally this is about where we stand, 200 to 250. For example, the mesh I just showed is about 100 gigapixels, so processing time was probably around 10 to 12 hours.
All right, our next question. Regarding reality analysis, which data formats are supported to perform all the operations that you showed?
So within Cesium Ion, it will be a point cloud, and it will have to be converted to 3D cloud. So main formats are supported. LAS, for example, can be dragged just like I did for the images, and there will be a conversion. It will be available for analysis. If we talk about iTwin Capture at large, we will be able to handle also images in JPEG formats.
Next question, do you already have any roadmaps to extend your library of AI detectors? Any new public models we could expect in the months to come?
we don't have a firm roadmap, but we've had many entries or requests around road and rails, so I hope it will be in this direction, and I hope we will be able to solve major workflows in this area.
Another question here. Is there a way to add external assets to a story, say a proposed design on top of an existing area?
Yes, that's doable. Just like I added my images at first, we can handle multiple formats of data, including design. So you will be able to bring it in here. I don't know the whole list of format, but this is documented on Cesium website.
Another question. Can you speak a little bit on the image matching process? Does it look similar to COL map or GLO map? Can I customize how I lose the image sequencing, how loose the image sequencing can be? And can I upload a COL map loose point cloud speed of processing?
So this is quite an advanced question. When you reconstruct a mesh, you bring your images in, and then if we summarize, there is a two-step process that goes on. First, we align the images, and then we reconstruct the mesh. The question here bears on the first step, the alignment of images, if I understood correctly. The alignment of images will occur if you don't bring any additional data. But if you already know this alignment, if you already know very well the position, the rotation, the calibration of your camera, you can bring this in iTwin Capture Cloud Service, not in Cesium Ion for the moment, but in iTwin Capture Cloud Service. You can not only inform the images, but also the images plus their position, rotation, calibration. So you leverage the already known and accurate information, so you get a more accurate reality mesh in the end. So yes, it is usable, not straight away in Cesium Ion. And about loose point cloud to speed up processing, not really for the moment. We will just take advantage of the image position and orientation, but not really from the existing loose point cloud.
Thank you for that. Another question here. As a legacy iTwin Capture user, how can I get access to Cesium Ion capabilities to share my models?
Well, you can go on the website I went when I started my live demo. You look for Cesium Ion, you will be able to create, if you don't have one yet, you will be able to create a community account and start playing with it, of course, with the limitations I mentioned, but that's probably a first step. Then if you're interested in more, stick to the website. You will have some links either for purchase or for sales discussions.
And we have one more question here for now. As a regular Cesium user, how can I access the full iTwin Capture suite?
Well, a bit the same answer. We have a dedicated Bentley webpage strictly for iTwin Capture. We have the dedicated webpage for iTwin Capture. You can purchase one product, the whole suite. We can purchase cloud service, but depending on what you require, you will either be able to purchase with a credit card from the website, or you'll need to go for a sales conversation and make sure you purchase the right product for your needs. So both entries are available.
We just got another question here. The model master usually requires the model engine. Can Cesium Ion have cloud-based processing?
Yes, absolutely. So this question refers to the original or legacy product around iTwin Capture. There was a desktop master, desktop engine. Now in Cesium Ion, all this is fused and triggering iTwin Capture Cloud Service, meaning the reconstruction doesn't occur on your own machine, it occurs on the cloud Bentley hosted virtual machines, and it just delivered the output results so you can enjoy it in your viewer.
Another question, is there any possibility to add tree detectors? I'm mostly interested in 3D reconstruction of large populations of trees for individual base analysis.
Very interesting question. So if you recall in the live demo, we have one detector for trees, but as told, it has been trained on a small sample, a sample that was only mobile mapping data. So if it doesn't match your regular data, it might not work. The only thing I can encourage you to do is to have a test. If it really doesn't match your expectation, we can have a discussion on how to create either a public detector for trees out of your data and see how we can move on, or a custom personal detector relying on your own data and your own labeling work to support training.
All right, Arnaud. Well, that does seem to be our last question for this session. Do you have anything else that you want to share or say to the audience before we close out?
No, just thank you for attending, and thank you, Jovin, for hosting this.
All right. Well, that will be it for today's session. If you were not able to ask your question, or if you have an additional question, you can reach Arnaud through his contact information that we have included in his speaker bio. And you can also email them to info@geoweek.com. I do have a few quick housekeeping notes to go over before we officially close out. If you could please fill out the short evaluation form that will appear on the webinar console shortly. This will help us better serve your needs in future webinars. As a reminder, the on-demand materials will be emailed to everyone within 2 business days. This will include a PDF of the slides as well as a link to the recording of today's presentation. And thank you again to Arnaud for an excellent presentation today, and thank you to all of our attendees for taking the time out of your busy days to join us. This webinar was brought to you by GeoWeek News and sponsored by Bentley. Thank you all and have a great day.